So I'm pleased to be here. I want to thank Mike Koenig for inviting me. I guess I have the only talk that's international, so I hope you enjoy this. We're going to talk a little bit about Eastern Canada, Appalachian-style thrust and valley ridge structures. It's in the Devonian, Silurian, and Ordovician reservoirs. And I'd like to thank, of course, my husband Charles Sternbach did a lot of the geology on this. I'm privileged to give the talk, but Charles' work is in this as well. And we work with a Quebec-based company called Munda Regina Resources, and I'm going to talk in more detail about what they do. They're a large acreage holder in Gaspe, and they wanted a G&G team to help them work out the geology, so we were very happy to get involved with this. Okay, Quebec, Canada is actually a new light oil frontier. It has announced a condensate discovery, which I'm going to show you where it is and tell you more about it. This condensate discovery has a very thick oil column, and along trend there's undrilled fairways and large structures. The location of the Gaspe Peninsula it's north of Maine, and so it's this little rounded piece of land that sticks out in Canada. It's north of New Brunswick, and it's also north of Nova Scotia. And down here is New York, and so we've been hearing a lot of talks in Ohio and Pennsylvania, and as I'm going to show, this area of Canada is right on trend with that. So the Appalachian Fold Belt goes through Alabama, through West Virginia. We were talking about Pennsylvania, and if you follow that along, you'll find that its northernmost limit is actually up in the Gaspe, Canada. So the reason why that peninsula is shaped kind of round like that has a lot to do with the mountains that are coming out of the Appalachian Basin. It's really the northernmost expression of the U.S. Appalachian Fold Belt. So I want to talk a little bit about this. Now we've zoomed into the Gaspe Peninsula, and there are a couple announced discoveries. There's the Galt field is the first commercial discovery, and there's also fields that are not commercial yet called Borg, Haldeman, and Tar Point. And people may think that this is an area you wouldn't want to get in because maybe you can't produce oil, or maybe that's one of your concerns. But I'd like to point out that there's two large ports here. There's Port Bonaventure and Port Daniel, and both of those are deep water ports, so they are planning to truck oil out of this Galt discovery down to these ports, and so there is a market right now. This is in no way stranded. So there are probably going to be some upcoming leasing opportunities in the Gaspe. The leases right now are held by just a few companies. There's Petralia, Munda Regina's in green, Junex, which is in the flesh color, and Mars Corp, and there's still some open acreage. And what happened with the leasing was Quebec really wasn't a productive oil province, and they opened it up for leasing prior to 2008. And these Quebec companies came in and leased up most of the peninsula for very little money, very little rentals, and they had a modest work program they had to do. All they had to do to keep their leases, other than pay their yearly rentals, was just do some G&G work like 2D seismic lines, cores, studies, reprocess seismic lines. And in Munda Regina's case, they did all that and they drilled a well, which I'll discuss a little later. But it was a very modest work program. And one of the reasons was that I think Quebec was on the fence on how much they wanted to get into the oil industry. They wanted oil, but they didn't want fracking, so they were concerned about what's going on in New York. And they basically froze the lease situation around 2008, so nothing expired. And so what's happening now, they've changed governments in 2015, and there is more interest in reopening up drilling. And so you can drill a well in Quebec, you just can't frack it. So what the opportunity here is the government's is now planning to redo the hydrocarbon law, make it more like Western Canada, and then they're going to ask to break up some of these big leases in here. Each lease in here is about 50,000 acres, and they're going to increase the rentals and require more activity on part of the operators. So the advice from Munda Regina that we're getting is that there's going to be some kind of shakeout of lease here, and they can't just sit on all this acreage just held in perpetuity, that they're going to subdivide the leases and they're going to probably have bid rounds, possibly this year, although I haven't heard what the movement is on that. but there could be upcoming lease opportunities that haven't been available for years in the Gaspe Peninsula. And people think that the Gaspe Peninsula must be a gas play, but it's really not a gas play. I think that thought came around because there is a gas field in Quebec called Flavian Field, different formations, and also it must be gas because the Appalachians have gas. But Junex, which is drilled this Galt commercial discovery, actually produces this straw-colored light oil out of their lower Devonian reservoirs. And so they have proven commercial oil, and the source rocks are in the oil window, they're not in the gas window. So I'll tell you a little bit about the Junex discovery. Junex is a Canadian company. They own that field 100%. And based on drilling about 5 horizontal wells in the lower Devonian, they have proven 71 million barrels recoverable on the unrisked prospective oil. They use horizontal drilling, and they own their own rigs. So the most important well was, information was released in 2014. The Galt number 4 yielded 7,200 barrels of oil at up to 300 barrels a day. And so this was with light stimulation, not fracking, but we're using horizontal technology. And they have since drilled a Galt 5, which I understand was successful. That was 8,200 foot lateral test, and they did a 3D on it. And so now they're going to proceed in a commercial development. So the key to gas-based production is not vertical wells, but horizontal drilling. And then what the goal is to intersect horizontal or intersect natural fractures which have hydrothermal dolomite in the fractures, and then this increases the porosity and permeability and results in commercial accumulations. So the Galt field in this drawing shows that it's really a flower structure. So the well that we were able to look at is called the Galt number 1. That was initial well, and that's a vertical well right here in the flower structure. And what they've done is they've gone now horizontally, even passing through these flower structure thrust folds, and they want to intersect the fractures. They're looking to intersect the fractures because, as I'm going to show you in the next slide, the fractures are open and they have dolomite in them, and they are producing most of the rate from the well. So they've gone both from one direction in here and then horizontal in the other direction. And what the field looks like on map view, and this is from their website, it's kind of a round feature in a superficial view, and the Galt 1 is right here, and one of the horizontal wells goes to the east, and probably about 5,000 acres, so there could be a lot of Galt and bigger size accumulations still left to be found. I'm going to go over a little bit of the geologic history and talk about when they started drilling oil, and I want to compare the stratigraphic column between Canada and the United States. So again, we're up here in the Gaspe Peninsula, just north of Maine. And this comes from the book, The Great American Carbonate Bank. It's a trend map of Paleozoic fields, and people in Canada may or may not be aware that they're on trend with one of the biggest gas and oil production trends in the U.S. Wilburton is way down here in Oklahoma, produces out of the Ordovician. And then there's Albion Scipio, the Lima, Indiana oil Trenton fields, and up and through Ontario. So it really makes sense that Galt Field is really one of the most northern trends of an existing play for both the Devonian and the Ordovician. I made this specially because I was very confused when I entered the literature on where we were in the section. All the names in Canada are completely different than in the US, but by using the European stages on several strat charts, I realized that they have a great source rock called the York River Shale, which is the equivalent of the Marcellus Shale. It's early Devonian in age, and I went to school in New York, and so we studied the Catskill Delta, But that's not present in this part of Canada. That's eroded off at the surface. So the superficial rocks are really equivalent to some sands that would be near the Marcellus Shale, and then there is a shale that's about 5 to 10% TOC. They call it the York River Shale, and that is certainly one of the source rocks responsible for the production at Galt. The Oriskany Sandstone and the Helderbergs have their equivalents, and these are also reservoirs in Galt Field. And they have the equivalent of Lockport Dolomite isn't present. It's limestones and shales. The Utica Shale has an equivalent, what they call the McCasty Shale. And so in the area that we studied, there are very few wells that go that deep. But we know it's there, I'm going to show in another slide, because the oil fingerprints of the Ordovician have been found in the Galt Field shales. So there's really two source rocks. There's a Utica equivalent in the Gaspe Peninsula, and there's a Marcellus Shale equivalent. And what's not often drilled is the Trenton to Knox. There's only 2 tests in the Gaspe Peninsula, and I don't think they've really tested that section at all. So the very first wells in Gaspe were drilled right about the time Pennsylvania was drilling the Titusville discoveries. 1836, there was some early wells. Up until about the 1900s, they were collecting oil on the surface of the Gaspe Peninsula, but quite a bit like Pennsylvania, they were vertical wells. They produced maybe buckets or a few barrels of oil, and so they just, they were like minor 49er people. They had to leave it. If they couldn't burn it in an oil lamp, they had to kind of leave it there. So the Gaspe really did the same thing as Pennsylvania. The oil industry moved to more lucrative areas. But in the 1990s to 2000, the government decided to become a partner in the petroleum industry. And even to today, the Quebec government is a major funder of wells drilled in the Gaspe Peninsula. Typically will be a partner with the Canadian oil companies, maybe up to 40%. So the government stimulated both seismic, gravity magnetic, all kinds of scientific projects, and quite a few more wells here were drilled between 1990 and 2000, about 82 wells. And recently there's much more than 19 wells, but that was what I had records for. So total, you're only looking at about 200 total wells in Gaspe since 1836. But what I found really interesting was we had a big spreadsheet from the scout tickets of all 200 wells, and over 23% of all the wells that drilled had live oil. And I don't mean like just shows on a log. I mean they had flowable oil. I had to translate it out of the French, but buckets of oil. So it's very, very common to have live oil shows both in wells and on the surface. And very few deep wells. So this bar is 84 wells out of the 200 in my set are only drilled to 1,000 feet. So only 2 wells are drilled at 10,000 feet. So the middle section is about to 4,000 feet. But the basins I know the basins go to 10,000 feet, and there's one area in the middle, it may have a 20,000 foot basin in the middle. So we have very, very low depth of penetration in Gaspe. So here's a superficial structure map, and you can see it's quite complicated, but the focus area that we think is highly prospective is the middle to lower Devonian fold belt, which is anticlines and synclines, quite a bit like the Appalachian Valley and Ridge. And it's also offset by some transpressional or strike-slip tear faults. So there's an Ordovician belt, a Silurian belt, and this is metamorphosed Cambrian Ordovician. So this part to the north is not prospective for oil and gas. We think this middle to lower Devonian fold belt is the place to go. Almost all the wells were drilled over here for various reasons. For one reason, there's a lot of seeps over here. Second reason, close to the shoreline to get, I guess, material in and out. And so they were kind of sticking with the success of the area. Very, very few wells in here. Virtually no wells down in this part of the trend. So there's 2 source rocks charging the section. I think we have the Marcellus equivalent is responsible for a lot of those seeps at the surface, and there is a very good sandstone called the York River Sandstone on top of that, and that's produced quite a few shows in the basin. But I think the Utica is also charging it from the base, And it's because the Galt Field, their reservoirs are in the early Devonian, the Indian Cove and in the York River. So something's charging both up the section and down the section. The tectonic setting is the Acadian orogeny, just like in the talk before me talked about the Acadian orogeny also deformed these beds, and it became the strongest toward the end of the Devonian. So these are the Great American Carbonate Bank carbonates being deposited, and right after deposition, after lithification, they're being deformed into thrust faults at the end of the Devonian, and I think this is also the time of hydrothermal dolomite emplacement. So the reservoir rocks in Gaspe, they're all middle to lower Devonian. They're really kind of a low porosity matrix interbedded with silt. The high porosity is in the hydrothermal dolomite, which is found in fractures, and they have seen some high permeability reefy bioherms on outcrop and in the core. So if you were to go on a field trip, and these are field trip photos, it's kind of a gray carbonate section, very silty, and generally not very porous, just in the average sample. But this is a core from Junex's Galt number 3 well, and they're just displaying for their investors that they have some very crystalline dolomite on a fracture here that the core penetrated, and that's exactly where they're getting much higher recovery of oil rather than the matrix porosity. So when we worked with Mundi Regina, they did do their own well on their own acreage in 2008. It wasn't successful. It was they'll call it a stratigraphic test, but the goal was to see whether or not the reservoir quality was as similar to Galt several miles to the west. So in this strat column, this is the strat column of the area, but this is the log that Mundi Regina drilled. And so the reservoir that it's present at the Galt Field is this C and D facies. It's probably a deep water shelfal. It's a clastic-rich carbonate would be the best way to describe it. This does not really have any matrix porosity, though they did do a lot of fracture logs, and there was fractures in the section, but there just wasn't a trap for this well, so that's the reason why we think they didn't find any hydrocarbons. But this well shows that there's widespread existence of the same reservoir in Galt. The well log correlation, this is the Mount Alexander well, and here's the resistivity, and these are the lower Devonian reservoirs. So they're about 2,000 feet thick, and this happens to be in meters. And here's the Galt number 1 well, where they crossed hydrothermal dolomite-rich fractures where those black dots are, and this is where they are now drilling horizontally and making the commercial light oil. So this is, again, just slightly thicker. So this is about 2,000 feet a section. It doesn't have any water in it. Once you're in the trap, you don't have any water, so you basically have a 2,000-foot oil column. Just to go over what the seismic lines look like and take a look at the structure, we'll go back and we're going to take a detailed look of the synclines and anticlines of the central Gaspe. So what we're going to look at is really fault bend folds. There's a ramp detachment in the Cambrian, and this is an illustration from a book from the Colorado School of Mines, but you can see how the anticlines form like an in-echelon parallel feature, and so this is very similar to the valley and ridge. And just to make things more complicated, the valley and ridge subsequently got strike-slip deformed in both the right lateral and left lateral sense by intersection with a plate, part of the Acadian orogeny. So this is some very complicated geology. They have done both gravity and magnetic work, and so on the Bugey gravity map, there's really, really thick basins here, maybe estimated to be about 20,000 feet of Paleozoic. So remember, the Galt wells are over here. We think they may have not even penetrated the thickest sediments of the Gaspe Peninsula. So this interesting cross-section here is done by the Canadian Geological Survey, and this is the part that's not prospective. It's all metamorphosed north of this Chickasha Sud fault. And then this is the more prospective area. From this fault to the Cospicale fault, there's a very large anticline depicted in color in here. And then there's also a series of both anticlines and thrust features right in here. And it ends with what they call the Grand Pabos Fault with the older rocks here at the surface. And let's just look at that in a little more detail. So there's a very important seismic line that I thought really illuminated this area. I'd like to share it with you. It's probably the best looking seismic line in this whole area. A lot of them are very hard to look at, but this one came out great. And it's going to be the interval between the Shiksat-Sud Fault and the Kaspakal Fault, delineating a major anticline. So here it is, and I'll have a blow-up of it in a second. So what you see here is you can track the superficial geology on this part of the line and get a pretty good idea of how it descends into the subsurface. But you can see that there is some little bit of fault bend folding going on here. And for the first time, you see about 10,000 feet of sediment. Like the speed of the velocity is about 10,000 feet per second, so 1 second is approximately 10,000 feet. So you can see possibly all the way down to the Cambrian here in this basin. And then this part of the line was of interest to Mundi Regina because they had acreage on this side of the line. And it seems that we had it reprocessed down in Houston, and it didn't come out quite as good as the northern line. But again, there seems to be at least an anticlinal feature here and another anticlinal feature here, that there's no wells at all in this whole area. So what we did was we made a stratigraphic column, not a real well, but a proposed well, based on the stratigraphy we saw intersecting the surface and the Mount Alexander well, which went to about here. And so what we think is that there's the Ordovician, Utica Shale, and Cambrian, and that this is the Cambrian and the Precambrian, like in a thrust sheet right in here. And if you drilled a well, you would be able to penetrate section they've never ever seen in Gaspe. But here's the likely source of that Devonian oil coming up. It's coming up from the Utica Shale. And then if you flatten on this, you find that you have an extra doubled thick section of possibly Ordovician, maybe Trenton and Utica, and Cambrian. So this is depositionally thicker than the other part of the line. And then if you flatten on the detachment, you can see the extra thickened part here. Mundi Regina has a prospect called the Champlain prospect that's based on that reprocessed 2D line segment. And that is, here's the nice anticline we saw on my flattened sections here. And so this part of the line, we're going to look at a series of thrust structures. And these also have associated surface oil shows. So we think that the Marcellus equivalent is buried in here because the sands of the Middle Devonian are on the surface. So there may be a very shallow play here, and then an opportunity to go through the Lower Devonian, Silurian, and encounter the Utica and Trenton potentially. So this is a large anticlinal feature that goes for about 30 miles on the surface. So basically the synform, this is about 67,000 acres, and the whole feature is about 30 miles long. And it's very similar also for this anticline, which doesn't have a well on it either. Again, you have about a 30-mile anticline with wells, or very old wells, or no wells at all. So the lease situation is Petralia owns the anticline that's up in the north, and then this is Mundi Regina's acreage on the Champlain prospect, and we think it's about 16,000 acres. So when they were out shooting seismic, they did encounter natural oil seeps on the roads, and so they were able to document that in photographs and samples. So we think that what we would recommend is some kind of conceptual project where you drill horizontal wells, maybe have minimal surface impact, and do lateral wells into the Lower Devonian in order to produce it. So the conclusions is there's a light oil play in eastern Canada and probably not a gas play. The source rocks would be the Marcellus and the Utica. And the old straight holes really poorly evaluated the light oil play, and now they're really only seeing the potential. Now they're doing horizontal wells. It's a transformative technology, And there are still a lot of undrilled structures, and because of the change of the Quebec government and their new hydrocarbon laws, acreage is likely going to be available in future bid rounds. So thank you very much.